The Master Algorithm: How the Quest for the Ultimate Learning Machine Will Remake Our World by Pedro Domingos is a book that explores the field of machine learning, its history, its current state, and its future prospects. The author, a professor of computer science and a leading researcher in machine learning, argues that there is a single algorithm that can learn anything from data, and that finding this algorithm is the ultimate goal of machine learning. He calls this algorithm the Master Algorithm, and he describes the 5 main paradigms or tribes of machine learning that are competing and collaborating to discover it. These are the symbolists, who use logic and rules to represent and manipulate knowledge. They believe that learning is a form of deductive reasoning, and that the master algorithm is a universal learner that can infer any concept from a few examples. An example of a symbolist algorithm is inverse deduction, which learns rules from data by finding the simplest explanation for it. The connectionists, who use neural networks to model the brain and learn from examples. They believe that learning is a form of pattern recognition, and that the master algorithm is a deep neural network that can learn any function from data. An example of a connectionist algorithm is backpropagation, which learns the weights of a neural network by adjusting them to minimize the error between the network's output and the desired output. The evolutionaries, who use genetic algorithms to simulate natural selection and evolution. They believe that learning is a form of adaptation, and that the master algorithm is a genetic program that can evolve any program from data. An example of an evolutionary algorithm is genetic programming, which learns programs from data by randomly generating and mutating them, and selecting the best ones according to a fitness function. The Bayesians, who use probability and statistics to model uncertainty and learn from data. They believe that learning is a form of inference, and that the master algorithm is a Bayesian network that can learn any probability distribution from data. An example of a Bayesian algorithm is Bayesian inference, which learns the parameters and structure of a Bayesian network from data by computing the posterior probability of each possible network given the data and a prior probability. The analogizers, who use similarity and analogy to learn from data. They believe that learning is a form of generalization, and that the master algorithm is a kernel machine that can learn any similarity function from data. An example of an analogizer algorithm is support vector machines, which learn a classifier from data by finding the optimal hyperplane that separates the data into different classes, based on a kernel function that measures the similarity between data points. The author then discusses how these 5 tribes can be combined and integrated to create more powerful and versatile learning algorithms, such as Markov logic networks, which combine logic and probability, or deep learning, which combines neural networks and kernel machines. He also explores the applications and implications of machine learning for various domains, such as science, medicine, business, education, art, and society. He examines the benefits and risks of machine learning, such as its potential to accelerate scientific discovery, improve healthcare, enhance creativity, and empower individuals, as well as its challenges, such as its ethical, social, and political issues, its limitations, and its dangers. The author concludes by presenting his vision of the master algorithm, which he calls alchemy, and which he claims is the closest approximation to the ultimate learner that exists today. He describes alchemy as a Markov logic network that can learn any logical theory from data, and that can incorporate any other learning algorithm as a subroutine. He argues that alchemy is a general-purpose learner that can handle any type of data, any type of knowledge, and any type of learning task, and that it can learn from both examples and feedback. He also suggests some directions for future research and development of the master algorithm, such as incorporating more human-like abilities, such as intuition, creativity, and common sense, and making it more accessible, understandable, and trustworthy for users. My opinion of the book is that it is a fascinating and engaging introduction to the field of machine learning, and that it provides a comprehensive and insightful overview of its main concepts, methods, and applications. I think that the author does a good job of explaining complex and technical topics in a clear and simple way, using analogies, examples, and stories. I also think that the author does a good job of presenting the strengths and weaknesses of each paradigm, and of showing how they can be combined and improved. However, I also think that the author is sometimes too optimistic and speculative about the possibilities and prospects of machine learning, and that he does not sufficiently address some of the challenges and limitations that it faces, such as its scalability, robustness, interpretability, and accountability. I also think that the author is sometimes too biased and partial towards his own approach and algorithm, and that he does not sufficiently acknowledge or compare it with other existing or alternative approaches and algorithms. Therefore, I would recommend this book to anyone who is interested in learning more about machine learning, but I would also advise them to read it with a critical and open mind, and to complement it with other sources of information and perspectives. Thank you for listening.